start this over.
Okay.
Are you recording?
Quit being rude. Let's go. So 12.3, guys, what it is it's using data displays. They start you off with a circle graph. Here's the thing with the circle graph. So, for instance, if you look at this one right here, okay, 75%. How many degrees are in a circle? 1 degree? 360. Okay, there's 360 degrees in a circle. So, as we can tell by looking at this, 75% is also 3/4. Okay, well, it definitely looks like 3/4 of this circle is covered by 75%. Okay, so the key with circle graphs is to tell how many degrees that you have to cover to represent some data. Okay, so that's the key with these. Now, that can be kind of tricky. The best way I know how to do it is with a protractor, okay, and then we would measure the degree on the protractor. All right, so that's what we're going to do today. We're also going to do a line graph too. That's what this thing sticks to, and then it asks you some questions on just different data displays, which we'll hit towards the end here. Okay, so it says a circle graph represents data as sections of a circle. Okay, notice one more thing here. Okay, if I were to take each of these percentages and add them up, what do you get? You get 100. Okay, so on a circle graph, you have to have 100% when you add them all together. Okay, that is different than, like, say, a bar graph or even a line graph, something like that. Okay, they don't have to do that. All right, circle graphs do. So it's a whole portion surveyed or something, and then they have to represent 100%. All right, so it says to make a circle graph, find the angle measurement to the nearest degree, which I'll show you how to do. It says that represents each data value's portion of the whole. It says the sum of all the angle measures must equal 360. So not only do you have to add up to get 100%, but you also have to add them up to get 360 degrees. Okay, it says the number of degrees in the circle. That's what we're talking about. Okay, so a couple different ways you can do it. All right. On this one, it says the survey asks how often do you check your email. Okay, now this book was made in, I believe, 2007. Okay, do you think that has changed?
Yeah.
All right. I would, and to be honest, that's when I was in college. All right. Did I check my email in college? Like twice. Okay, in 4 years. All right. Now I check it every single day. Okay, and pretty much everybody goes through email now. All right. So this has probably changed a little bit. But I do know jobs that, yeah, people don't check their email still. Okay. So it's an interesting problem. It says of 100 people asked, 4 responded less than weekly, 23 responded weekly, and 73 responded every day. So it says display the data in a circle. Okay? Now, percentages are pretty easy to find here. Okay? Because they're all out of 100. All right? So, for instance, if I want to find out 4 responded less than weekly, what percent is that? Well, if it's out of 100, it's 4%, right? Okay? So, you can do this one of two ways. Okay, understand it's not always going to be out of 100 people, right? So you could have any number you wanted to. So the way we can do this, I'll show you the 2 different ways, is if I want to find the responded less than weekly, I could say 4 out of 100, and then to find out how many degrees this covers, I could go ahead and I could set up a proportion. So I could put D over, not 100, but 360, okay? Because 100% of a circle is 360 degrees. That's why I can do that, okay? From here, I cross multiply, I solve for the degree, okay? You can also simplify this right away. You could just say, let's see, that is a 1. This would simplify to 25, so 25 times D equals 360 times 1, okay? So 360, and then divide by 25. Okay, I think it's a decimal if you do it. You can't. That's a great question. Okay, can you cross reduce across an equal sign? You can't. No, it's only the fraction themselves. If it was multiplication, yeah, but if it's an equal sign, no. Okay. Divide 360 by 25. It goes into 36 once. All right. We still got 110, so that'd be 4. Let's see. You got 100 left, so that'd be 4 as well. Often with circle graphs, okay, it's not worth doing a decimal, okay, because if you look at your protractor, you're not going to see a decimal, right? Okay, so let's probably just go ahead and round this to 14. All right, so that's one way you can do it. You can set up a proportion. So this would be let's just do this, less than weekly, okay? So less than weekly. Okay, so we're going to do this on example 1. We're going to find these out, and then we're going to put it into the circle graph, okay? It says 23 responded weekly. So here's the other way you could do it. If you know that 23 is 23%, okay, you could do it like this. You could just say 0.23 times 360. Okay, that's another way you can do it if you know the percent. All right, change it to a decimal, multiply it by 360. You should get the amount of degrees covered by 23%. Okay, so go ahead and do that once. See what you get. Tell me what you get. I think it's
82.8.
okay. I was gonna say I think it's 80 something. Okay, 82.8. All right, and again, it's not worth having a decimal probably. So we're gonna go ahead. We're gonna say that's roughly 83 degrees. Okay. Okay. So this one here it says that is the weekly one. Whoops. So we're going to go ahead and I'm going to label that so I know what I'm doing when I make my circle graph finally. Okay, and then finally we do have to do the 73. So I'll show you the proportion way one more time because that works every single time. This one works, but it's a little tougher to do if it's not exactly 100. Okay, so we're going to go ahead and go 73 over 100, okay, and then the degree over 360. So if I were to cross multiply that, I have 73 times 360, and then 100 times d. Okay, divide by 100 on both sides, and you should be able to solve the problem. All right, you could even simplify it before you multiply. That would actually work too. All right, so go ahead and do that once, see what you get. Okay. Anybody get it? Not yet. Or you can just take 0.73 times 360.
That would be 260.
What's that?
260.
Okay, 262.8. Okay, so we'll go 263. Okay, so 263 degrees. All right. So let's go ahead, once we know these things. So these are what we're going to graph here. We got 14, we have 83, and we got 263. Okay, so now I'm going to go ahead, I'm going to change to my my overhead projector here. Let's see, I used to have one. Where the heck did my protractor go? Oh, there it is, right in front of me. Okay, so get my protractor handy. Protractors make it pretty easy to draw a circle. Okay, so I'll show you how to do that. Really, all you got to do is trace the top and then trace the bottom. And I got a pen, but I'm going to use a pencil here. Okay, so let's go ahead and pop that up here. All right, so hopefully you guys can see this okay. I can back it out if you can't. Okay. Okay, so first off, when I make a circle graph, what I want to do is I want to have a label on top of the circle graph. All right, so act like somebody's walking up to this circle graph or looking at it, and they don't know what you're talking about. Okay, so what this was making a circle. It says, how often do you check your email? You don't have to name it that whole thing, but maybe like check your email. Okay, so that would work for the or people checking their email. Okay, something like that. I'll just say check your email. All right, so first off, I'm going to say check your email. Okay, so that's what we labeled it. All right. My second step is to make a circle. All right. So I'm going to go ahead. I'm going to put my protractor down. Okay. I'm gonna go and I'm gonna make a circle, but I'm not gonna go all the way around the protractor. I'm gonna stop at this line. Okay, you guys see that? Okay, that is the 180-degree line. So I'm gonna go ahead and I'm gonna do that. I'm gonna do my best at this because I'm drawing challenged. All right, Jacob, you know what I'm talking about. Okay, and then we're gonna go ahead. We're gonna flip this over. We want to align that. I'll move this here in a second. But we want to align that with where you stopped the first time. Okay? I can already see I'm sort of challenged with my circles. I'm a little bit off. Okay, I'm going to clean that up here. It doesn't have to be perfect. Okay, but that's what I want to do. The other thing I probably should have done right away is to signify my center of my circle. All right. Okay, so the first one that we're going to label. Is everybody okay on this?
Not really. I'm challenged too.
Okay, that's all right. That's all right if you're challenged. Could you imagine if we had to learn how to use compasses in the same day? Okay, it would have been. We'd be doing this for 6 years. All right. Yeah, that's good to go. Okay, so the next step is you want to designate your center. Okay, so if I'm going to do that, I'm also going to designate. I'm going to designate this. I'm going to go to the side. I'm going to put a little notch on 180. Okay, so that way I know where to draw my line in when I designate this first measurement. Okay, so I believe the first one we found was 14, right? Okay, so what I want to do is, there's numbers, usually with most protractors, there's numbers here on the top, and there's numbers on the inside as well, okay? So I want to look at the numbers on the inside, because you might notice they start at 0 here, then 10, then 20, okay, then so on and so forth. You want to go to 14 and make a little notch, all right? The next measurement was 83, I think. Okay, so 83. Now, you got to keep in mind, this is 14. So, we have to add 14. Okay, this was 14 degrees. Okay, we got to add 14 degrees to 83. All right, so 14 plus 83, probably you can do in your head, is 97, right? Okay, maybe you can't. Okay, 97. So, if I go to, what's that? Oh, I think. So if I go to 97, okay, 97, remember, we got to look at the bottom ones. Okay, 97 would be about right there. Okay, now on this one, we're only going to do 3 different areas. So right now, I actually have everything done. Okay, all I have to do is draw this out. So I'm going to go ahead and make a line across where I put my notch. Actually, I'll just do it one way. Okay. And then I want to go ahead and line this up. So I'm using this straight edge on the protractor to do the best I can. Okay, so, again, this is an algebra guy doing geometry, so I apologize in advance. All right. Okay. So, since we have so much room here, we could probably just write right in the areas that I have. I could label it what it actually is. Okay? How are we looking, guys?
Terrible.
Need an eraser? Okay. I have one on my pencil here, but you might want to go grab one if you need an eraser after this. Okay? Just hang out for a second, and then at the end of the lesson, if you want to grab one. Okay. Okay, so my next step, okay, I'm going to erase my 14, all right? My little area there in the bottom right is going to be this. It's less than weekly, okay? So we're going to label it right there, okay? So 4 people responded, 4 said less than weekly, okay? The next one was, I believe, 23, and I think that was once a week. Okay, so we'll say 23 responded one time. All right. So one time a week, and then finally, I think it was 73. Right? Okay, 73
Do I go to 97 or 100 when I go straight up?
responded 1 second.
Neither. Okay, we're gonna do.
All right. 73 responded every day. Okay. What's your question there?
Steel's just confused on how to do this.
Yeah.
Challenge? Okay, so let me review how I did this. Okay, because it can be challenging the first time you do it. All right. Let me just talk about what I did first. Okay. So first off, okay. So make sure you're listening if you're confused. All right. So first thing I did was I started. Okay, by doing this. Remember, I drew the circle. I also designated the middle of my circle. Okay, the center of it. All right, and then I went and I flipped it over, and I went back and I did the same darn thing to the bottom. That way, I got one big circle. Makes my life easy. It's a lot easier than using what am I looking for? A compass. Okay, so the way we do it after that, we know the degree measurements that we need to use. Okay, so I went ahead and I did this. All right. Okay, and then I went ahead and I found 14 degrees because that is my 4 was less than weekly. Okay, that was my 14 degrees. All right. My next one, I knew that I already took up 14 degrees. Okay, and then the 23, I believe that was 84 degrees. Okay, so since I'm already at 14 here, I have to go to 97. All right, and then I went ahead and I made a notch at 97. I know that there's only 3 spots here. So what I can do then is I know the rest of the graph would represent the 73 responded every day. Okay, so I knew that that was the 263 degrees or something like that. Okay, so that's how I did that. I also have my label up top. Okay, and there's my circle graph. Okay, so that is how you do a circle graph. Okay, it can be a challenge. It takes a little bit of time, but that's why you're not going to do 500. Okay, you're probably going to do 1 or 2. Okay, if you would like to ask me how to do them as you are doing them,
Steel needs help.
you are welcome. We check out. Oh God, I'm just kidding. That's fine. It's I like this lesson because we got to do something with our hands, and we don't always do that in this class. We do a lot of algebra. That is a great one. Good job. Okay, you're going to be a statistician one day there.
No thanks.
All right. It makes a lot of money. $120,000 a year, bud. All right. That looks good.
Yeah, see, I'm not telling you.
You aren't. All right. You'd be a craftsman one day. You can make chairs for somebody. There you go. Okay, let's take a look at this next one. So, if you struggled with the circle graph, this one's not all that difficult. It says the line graph uses line segments to connect data points. A line graph is often used to represent data that change over time. Okay, so this one here says the table shows the number of insect species on the United States endangered species list. It says make a line graph of the data. Okay, so here's what we're going to do. This one requires an XY coordinate plane. You only have to use the first quadrant, all right, because everything is positive. You also have to be careful not to deceive people when you make this. Okay, so in fact, there's a portion I'll show you tomorrow that I'm talking about that would deceive people. Okay, so this one here, all I'm going to do is I'm going to make my XY coordinate plane. Okay, I'm going to label the bottom part the years, and I'm going to label the vertical part. We're going to label that the number. Okay, so that would be the number of endangered species. All right, so it starts at 1994. You have 2 choices. You can call 1994 year 0, You could make a key underneath it and call it that, or we could just go with 1994. I would say in this situation, just go with 1994. Okay, so here's my first one. There's 1994, not 1194. That would be a big change. I don't think they were keeping track of endangered species in 1194. Okay, but that's the first one. 1996, 1998, we got 2000. If you can write it sideways too, that'd probably be a little better than what I'm doing. And then 2004, okay? Okay, so the number on the side, let's go, since it goes with 19, it goes all the way up to 35. I believe the book on this goes by tens, okay? Let's go ahead and do the same thing. Let's go 10, 20, 30, and 40. Okay, so we're going to put years down here. And then I would put endangered. And if you can write it sideways, that's great. I have to write it vertically. So endangered insects. Okay, so endangered insects, all right? And then really the line graph from there, all you have to do is go ahead and go to the years and then put in the coordinates. Okay, so 1994 is 19, that's almost 20, so we're going to put a dot there. 1996 is 20. 1998 is 28. All right, and then 2000 is 33. 2002 is 35, so a little bit higher, and then 2004 is the same darn thing. Okay, so from there, just connect the dots using line segments, okay? And then that's how you represent a line graph, all right? It's pretty darn easy. Just drawing the line segments and then putting them together, okay? Any questions on that? Okay, so next thing, all right? The last thing we'll talk about is this. It says using appropriate data displays. Okay, so for instance, that last one, would it have been a good idea to use a circle graph on the last one? Okay, probably not, right? Okay, so, and then these give why these things are good to use. So, for instance, circle graph says to represent the data as parts of the whole. So that means, if you think back to that first one, they surveyed 100 people. We can represent 100% with the circle graph. Okay, so that's a pretty good choice of representing that data. A line graph is used to display data over time. Okay, so a line graph is really good if you're using it as a display over time. Okay, so like volcanoes erupted, line graph. Okay, if you keep track of it by years. All right. Okay, so it says the third one. The third one we talked about a little bit. It says stem and leaf plot. That's a good way to organize your data. All right, so organizing your data. If you got a bunch of data, a stem and leaf plot, if you're doing it by hand, is the way to go. Okay. The fourth one here says use a box and whisker plot to show the data's distribution in quarters. So that's fourths. All right, that's what we talked about yesterday. A bar graph used to display the data in distinct categories. Okay, so if you had, let's talk about volcanoes again. I don't know why I'm talking about volcanoes, but if you want to know the amount of volcanoes per country, okay, you can have the country listed on the bottom and then the number of volcanoes listed on the side. Okay, that's a pretty good way to distinguish each different country and the number of volcanoes they have. All right. Venn diagram. Venn diagram, you guys haven't dealt with that much. Okay, but let's talk about it real quick. Students that get good grades and what color shirt they're wearing. Okay, so let's think about it. So you probably have 3 different colors of shirts. You have a green one. Okay, I should intersect that actually.
I got a question.
Yeah, 1 second. So what that would look like is this. So I'm gonna do my best to explain this. All right. So what's up?
What's our shirt change every day?
We'll just say today. All right. So good question, Will. So let's say that you're wearing a blue shirt. Okay. These are the people that wear blue shirts. These are the people that wear green shirts. These are the people that wear red shirts. All right, so there's a certain amount of people in there. You can mark them. The people on the outside get maybe bad grades, and the people on the inside get good grades. Okay, so these guys in there would coincide with each other. Okay, probably not my best explanation of that, but you can have two things, and then you might be wearing a different shirt. Let's say Steele's wearing a black shirt, Ryan's wearing a green shirt. Okay, they can both get good grades. That's where it would intersect. All right, that's a Venn diagram. What's that?
It's wrong. I'm wearing green and red.
Oh, you were in green and red? Okay.
But it's wrong.
You're right. But anyway, that's my best explanation of a Venn diagram. It's used a lot in physics. Okay, who invented it?
Albert Einstein. Some guy named physics. Venn.
Venn. All right, the Venn diagram. Okay. Venn. I'm not sure if that's his full name. No. So it is not. It was not Venn Diesel. Okay. All right. So it says use a histogram to compare frequencies of data that are grouped in equal intervals. Okay. So that's something like it shows different intervals. Let's say that amount of volcanoes erupted. Okay. There'd be certain frequencies in given years. Okay. So that would be a frequency one. Also with histogram, notice how the bars touch each other. With the bar graph, I say that right, they don't touch each other, okay? So let's do these last two, and then we'll do our homework tomorrow. It says, the table shows the results of a survey that asked students if they are going away during summer vacation. We're not even, I guarantee that somebody is going to make graphs today of this, all right? It says, choose the appropriate display. So I'm not going to write it down, let's just talk about it. What do you guys think here? Okay, I would agree with you. It is a circle, okay? Because if you add all of those together, they represent 100%, okay? If you do letter B, what do you think? Line would be okay? Yeah. I'd probably say a bar. That would be the best one, okay? Because these here, those are specific categories, okay? That goes well with a bar graph. These, if you add them up, the percentages, they do not represent 100%. Okay, so circle graph is out. All right, but if you want to look for something specific, that would be a bar graph. All right, so that would be the best way to represent that data. And you could just say because it represents specific categories. All right, okay, that's everything today. I can. How long?